Hey guys, welcome back to my series on solving LeetCode problems, easy to hard. So now we're going, I'm not a premium user, so I guess I'll just skip this one. Intersection of two linked lists. Given the heads of two singly linked lists, at A and at B, return the node at which the two lists intersect. If the two lists have no intersection at all, return no. For example, the following two lists begin to intersect at node C1. The test cases are generated such that there are no cycles anywhere in the entire link structure. Okay, so we can assume that. Note that the linked lists must retain their original structure after the function returns. Okay. Interesting. Okay, so custom judge. The inputs to judge are given as follows. Your program is not given these inputs. Intersect val, first linked list, second linked list, skip A. The number of nodes to skip ahead in list A, starting from the head to get to the intersect node. Okay. Okay, cool. So what we can do, what can we do? Let me think of a smart way to do this. We can't really go back because we don't have like a previous thing here, which would be very helpful. But we can just go forward until we find. We can always just store the memory values. We can do that. I think. I don't know. Okay, the dumb way would be iterate over the entire A and then then check if it's the B's first index. No. B moves one index, iterate over A. No. Same thing. I don't know. I'm trying to think of a smart way to do this, and I have no idea. So I think let's start with something, even if it's bad. Um, yeah, we can't really save it. Okay, what we can do is have a dictionary, which is vowels of A, which is a dictionary which has an integer, which is going to be the value, let's say, of 4, 8, 4, and then it's a list of list node. We can do that. And it starts empty, and same thing for B. And then we can see something like, can go like, okay, while 3. And let's move 4 steps of list A, and then 4 steps of list B. Not list, like link. Yeah, link the list. Let's move 4 steps of A. So while head A, if if head A dot val is not none, then no, val will never be none. If ed A is not in vals of A, we can just go and vals of A dot val equals empty list, and then let's just append the array, and add a, but I want to do it 4 times, so 4 in range 4. If not, add a break. Okay, and now same thing. So while add a and head b, can do that. And now the same thing for b, head b, and if I don't want to check, I don't want to save the values of head b. I want to check if they are present in ed A. If ed B val is not in vals of, is in vals of A, then we need to check. So for potential match in vals of A of head B val, if potential match equals head B, return head B. And if nothing, return none. So let's run this. Maybe you didn't see the code here, but syntax is not. Oh yeah, it's. This is because I'm like speaking out loud, and I'm just like writing in English instead of like writing in Python. Limit exceeded. Yes, of course it exceeded because. And what I need to do here is add a equals add a dot next, and the same here. Add b equals add b next. I forgot to move to the next one. Add a is not defined. Yes. So it's not. Run. Okay, it worked. Submit. Wrong answer. Wonder why this didn't work. Because it worked for everything else. And I really don't want to try all of this locally. So this input is intersect value at 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. So this 14 meets. Yeah. Okay, I get it. Because I'm moving 4 together and B might be ahead of A. So what I should do is I can even like while at A. That was a stupid thing to move them together. So I'm just going to move this back and then while head B. I wanted to be more efficient. Didn't really work. Okay. So what I'm doing is I'm going all the way to the end with list A, and then I'm going with list B. And if I find a similar value, I compare to the ones that I saved, which is not the most effective thing ever. So let me check the solutions. What did people do? Very easy two-line solution. They just iterate linked list both pointers, and if there's one that reaches, yeah. Actually, this is smart because if they meet, the last one will be the same. So I'm kind of like, yeah, I'm being pretty dumb. Let's just do that. Let's see if that's better. So while at A, while head B, return at A equals head B. That's actually very simple and smart. What? Well, object has no attribute val. Oh, if they're the same, return head A. Oh, yeah, now I need to go back. If they're different, I return none. So now I need to. Oh, I would need to go back. This is not that smart. Let's see other solutions. Well, if I wanted to go back, I would have to save all of the things. Okay, so this one, I found most solutions use pre-processed linked list to get the difference in length. Well, it's not what I did. Actually, we don't care about the value difference. We just want to make sure 2 pointers reach the intersection node at the same time. can use 2 iterations to do that. In the first iteration, we will reset the pointer of one linked list to the head of another linked list after it reaches the tail node. The second iteration will move 2 pointers until they point to the same node. Our operation in the first iteration will help us counteract the difference. So if add hey is none, okay, return no. Add A, add B. If A and B have different length, then we will stop the loop after second iteration. While A is different than B, this work? I'm not seeing 2 iterations. If A equals no, then while A is different than B, if A equals no, A equals FB, else A equals A max. If A is no, then assign head of B to A and start iterating. B is no, then B is at A. I don't feel like this is better than what I did. Really, I don't. Simultaneously until both of them are the same. Okay, that's actually pretty cool. And the and in which case, where do I return none? Oh, if they meet at the end, then it's none. Then it means there's nothing. Okay, cool. Hope you guys learned something. I did. Enjoy.